Late in the Viking Age, a ship is being prepared on a Scandinavian shore. Water containers go aboard. Then sacks of meal, dried fish, butter, cooking gear, clothing, tools, and weapons. Every load solves one problem. Every load also makes the ship heavier. This is how Viking ships were supplied for long voyages. The first thing to understand is that there was no single Viking ship. Different hulls solved different problems. The large longship known as Skuldelev II was built to carry many warriors at high speed. Its long, narrow hull could move under a large sail and could also be rowed by a large crew. That gave it speed, but a crew is also cargo. Every person occupies space and adds weight. Every person needs water, food, clothing, and equipment. Add more men, and the ship gains military power while losing some of the space and weight margin that could have carried supplies. The ocean-going cargo ship Skuldelev I was built around a different compromise. Its hull was shorter and much fuller. The rounded form created far more room for cargo, while the crew could remain small. The museum reconstruction, Ottar, can carry about 20 tons with a crew of roughly 6 to 15. That is not simply a larger storeroom. It is a different logistical machine. And the most difficult supply was probably the simplest one: water. Food can be changed before it is loaded. Fish can be dried. Grain can travel as meal or flour. Bread can be baked. Butter can be stored. These foods still have weight, but preservation concentrates useful calories into supplies that can survive movement and time. Water does not cooperate. 1 liter still weighs about 1 kilogram. Experimental voyages make the consequence visible. During trials with the Sea Stallion, the reconstruction of Skuldelev II, the Viking Ship Museum found that drinking and cooking required at least about 3 liters of water per person per day. With 61 people aboard, that is more than 180 liters every day. 5 days approaches a ton of water. That is a modern experimental measurement, not a surviving Viking ration list. But the physical constraint is the same. More crew means more water. More water means more weight. More weight means less margin for everything else. So the real question was not simply how much a ship could carry. It was how long that load could keep the people aboard functioning. Archaeology gives part of the answer. Ship burials, such as Oseberg, preserve food vessels and cooking equipment. Later written traditions add another layer. Saga material and old Scandinavian legal texts describe provisions and shipboard routines. Although they were written down after much of the Viking Age and have to be used carefully, together they suggest a practical diet built around durable foods: meal or flour, dried fish, bread, and porridge cooked in large pots. This was food suited to transport. It could be divided, it could survive handling. Much of it did not require elaborate preparation, but some of it required water and heat. That brings the shore back into the system. For many Viking Age voyages, sailors moved through coastal waters, straits, rivers, and streams. These routes helped with navigation, but they also created repeated opportunities to land. A landing could mean fresh water. It could mean a hot meal. It could mean repairs. It could mean more provisions before the next exposed section of the route. Old law texts, cited by the Viking Ship Museum, describe a warship cook going ashore to fetch fresh water and prepare hot meals. The important point is not that every crew followed one fixed routine. It is that the ship did not have to operate as a completely self-contained floating settlement. The coast could become part of the logistics. That was especially valuable on a crowded longship. Imagine the physical arrangement. Rowers and sailing crew occupy much of the working space. Shield, weapons, clothing, lines, and personal equipment have to remain accessible. Water containers must be secured. Food has to stay protected from spray and contamination. Heavy loads also have to be placed so they do not ruin the ship's trim. There is no unlimited hold beneath them. Every object competes with another object. So Viking maritime logistics begins to look like a range equation. Add people and demand rises. Add water and food and weight rises. Add more cargo and the remaining margin falls. Reach a safe landing and part of that calculation can begin again. This also explains why different ship types mattered so much. Skuldelev 2 represents one extreme, many people and high speed. Skuldelev 1 represents another, a small crew and a large cargo capacity. The 5 Skuldelev ships include warships, traders, and smaller working vessels. Archaeology therefore shows a maritime world in which hulls were already specialized for different tasks. That does not prove that every Viking fleet sailed with a formally organized supply squadron. But it does show that Viking seafaring had the ship types needed to divide the transport problem. A fighting ship did not have to be the best cargo ship. A cargo ship did not need dozens of rowing. The design of the vessel could determine what kind of burden made sense to place aboard. On longer open water voyages, that distinction became even more important. A coast offers frequent chances to reset the supply calculation. The open North Atlantic does not. An ocean-going cargo ship, such as Skuldelev 1, had the capacity and seaworthiness for a different kind of transport. More hold space could carry provisions, tools, trade goods, or other heavy loads with far fewer mouths consuming the supplies. But even a cargo ship did not escape the equation. Every additional person still consumed water. Every barrel still displaced other cargo, and time remained uncertain. A favorable wind could shorten the voyage, a calm could lengthen it. A storm could force the ship away from an intended route or landing. Damage could turn a comfortable reserve into a necessary one. Provisioning therefore had to cover more than distance. It had to cover delay. This is where the famous image of the Viking ship can be misleading. We tend to see the hull, the sail, the oars, and the people. Those are the visible parts. But a voyage also depended on containers, preserved food, water, loading decisions, shoreline knowledge, places to land, and a ship design suited to the burden it carried. The ship was not carrying unlimited independence. It was carrying time. Each container of water bought more of it. Each supply of preserved food bought more of it. Each safe landing could reset the calculation, and every extra person made that calculation harder. The remarkable part of Viking seafaring was therefore not only that these ships could cross difficult water, it was that sailors could match people, provisions, hull capacity, route, and weather closely enough for the ship to keep moving. The hull made the voyage possible, subtly determined how long that possibility lasted. And, beyond the last familiar shoreline, there was no warehouse waiting beside the road, only the next landfall. So what made those sea routes reliable enough to use again and again?